Hi everyone, welcome back to our hypothesis testing. And in this video, we will be focusing on review exercises 5 and 6. And these two examples are the reverse kind of question, right? So they will give you the conclusion, right? They will already give you the conclusion. And what we need to work backwards is we may need to find back the unknown population mean, we may need to find back the unknown population variance or even sample size, or even to find back the significance level or even the sample mean. So there's many things that we can work backwards towards, because in as we've seen in the previous examples, we have we need many different quantities to make this test happen, right? So the thing is that we have quite a number of variables that we can work backwards to find given the conclusion, right? But then again, that means that we will also need other variables to be there except for one, and we'll just make use of the others to look for that one. So usually it will be like that in our syllabus. Okay, so without further ado, right, let's try out review exercise 5. And from 5, what I would like to tell you is that the setup phase, which is step 1 to step 4, are still the same. Okay, so if you were to remember this list over here, 1 to 4 will be the same, right? And 5 to 7, right, will be a bit different because we may need to go backwards, right, to work on maybe sample mean value or some, calculate some other quantity that we may not know, right? So we still need to set up as usual, right? But for the testing part there, we will need to change some of the orders of the steps so that we can work backwards to find what we need to find. Okay, so with this, let us start off with review exercise 5. Okay, so let's read this and process this together. Melons produced by a food grower, okay, grow under usual conditions, are normally distributed, which is very beautiful. Okay, we have a mean mass of 0.6 kg, standard deviation of 0.1 kg. Now, once again, let us decipher which kind of quantity is this. Is this the population or is this the sample, right? This one over here refers to the population mean mass because they're talking about melons in general, and they are talking about the standard deviation in general. So this refers to the population standard deviation sigma, small sigma. The food grower decides to produce a crop organically, and a random sample of 75 melons is taken, sample size n, right? So they have random sample of 75 melons had masses x kg, summarized by this data over here. So this summarized data, right, the sum of x, right, would help us to find sample mean. So this quantity actually is for our sample mean. Okay, right, as we've seen in the previous examples, right, the summarized data for this one would be for our sample mean. Okay, so part 1, we need to state the range of values of the that the sample mean must lie in. Okay, to conclude that at 10% significance level, so the alpha over here will be 10. Okay, that melons grown organically are heavier. Okay, so melons grown organically are heavier. So this one over here, right, would be mu greater than 0.6, heavier than 0.6 kg. Okay, so this one over here would form our alternative hypothesis, and this one over here would be our null hypothesis on top. Okay, so from here we can roughly see which one to look at already. Okay, on average than those grown under the usual conditions. Okay, so now this question, right, is that everything is given to you except for sample mean. Okay, so now let's set up as per our usual steps. So we're going to do step 1 to step 4 as usual. Okay, so step 1, let us declare our random variable and the population mean mu. Okay, so once now we've done this, we're going to look at our step 2, null and alternative hypothesis, which we've already seen to be given over here in the question, right? So the null hypothesis would be mu equals to 0.6. Then this one, the alternative one would be greater than 0.6. This one over here would be, let's say no one claim, but this one is just heavier, right? And okay, I will just mark this here that this is our conclusion. Okay, conclusion. So means, right, we already rejected H naught. So this one don't need to write. I'm just writing for me to note this in the back of my brain. Okay, something like that. Okay, step 3. Let us declare our test statistic. Okay, because we are looking at sample mean, we are going to need the distribution of the sample mean. So under, right, the null hypothesis, right, under the null hypothesis, because we already have very nicely the normal distribution for this quantity, so very nicely we don't need to do any central limit theorem. We can just take this, okay, and do this. So this would follow a normal distribution, and this would be 0.6. The standard deviation over here is 0.1, so variance we need to square, and the n is going to be 75. Okay, just like that. Okay, now next, if you were to do if you need to standardize, then the standardizing procedure would give you z equals to x bar minus of the mean 0.6 divided by the square root of 0.1 square over 75. Okay, something like this. And this one over here would also follow a normal distribution of 0 and 1. Okay, so now we've set up our test statistic already. Then we are going to state our test and the significance figure. So we will take one tail test to the right based on this quantity over here. So take a one tail test to the right, at 10% significance level. Okay, and I think, to be honest, 10% is pretty generous. Okay, all right. So let's see this visually how we would do. Okay, so we are going to have a visual over here like this, and this is a right tail test, and this area over here I will set it at probability 0.1, which is equivalent to our 10% significance level on the right hand side. Okay, so now I'm going to present to you perhaps two methods, all right, on how we can do this. And for this, I will split it right now into two different sections. Okay, so now that we have this visual already, right, I will bring you through two different methods to go about this. Okay, and these two methods will be using the critical value method. Okay, so the thing is that we cannot really use the p-value method over here because we don't have an exact sample mean for us to calculate our p-value, right? So the thing is, it will be definitely less than 0.1 for it to be rejected, right? But we don't have the exact amount to work backwards, right? And so because of that, right, the p-value method would be a little bit lacking, right? When usually when we work for backwards question. Okay, so because when we have certain unknowns somewhere in one of the quantities, right, we can't really calculate the exact p-value lah, right? So the thing is that the only method that we can rely on is to make use of the critical value method, right? And with the remaining two kinds of values that we can refer to, which is the z value or the sample mean value. Okay, so let me bring you through method 1 in how to calculate our z value, right? And so with critical value method, right, it will be advisable for us to write down the critical region, right? So over here we have our critical region. Okay, so based on this diagram, right, the critical region is that we will need to reject H naught, or to state the rejection region, right? Reject H naught if, okay, if the p value, right, is less than 0.10, right? So this one actually don't need to write, right? So the thing is that usually we'll just need to write down the z calculated value. Okay, so if the z calculated, right, is actually greater than this value over here. Now the problem is that we don't know this value, right, but we can work it out because this is 0.1, right? And what is this value over here is just a very easy method of doing the inverse normal. right? So let me toggle my calculator. Okay, how I will use the inverse normal, right? Key in my area over here, key in my mean and standard deviation, because this is a very nice standard normal distribution. Standard normal distribution, yes. Okay, so the mean and standard deviation will be just 0 and 1. Mean and variance are. Okay, and at the same time also, right, if you're using the z-value method, we should be standardizing in the previous step. Okay, so the z calculate over here, right, okay, would be, okay, it should be greater than 1.28155, right? So this value over here should be 1.28155. This is 0, this is z. So okay, so in order to reject, right, it should be over here lah, right? Okay, so now once we've stated our critical region already, let's relook at the conclusion. So the conclusion says that it is heavier, right? To conclude that these are indeed heavier, so this means that we are going to agree with the null hypothesis and agree with the alternate hypothesis and reject our null hypothesis. Okay, so over here, what do we do is that we are going to state the conclusion and we're going to work backwards from here, right? So for the conclusion is that the melons are heavier. So for melons to be heavier, right, and H naught needs to be rejected. Okay, and when H naught needs to be rejected, right, indeed the Z calculate over here will be greater than 1.28155. Now the thing for this is that the Z calculate, right, would be this quantity over here. We will make, if you remember from video number 1, right, part 1, we made use of this expression over here to calculate the Z calculate, and just nice we have our missing sample mean that we can calculate over here. So this over here refers to the distribution, but when we calculate the actual value, right, I'm going to use small letter x, okay, minus, okay, following this expression over here, okay, minus 0.6, okay, and then divided by 0.1 square over 75. Okay, so something like this. Okay, so this one over here should be greater than 1.218228155. Okay, right? So then the remainder is just to do some algebra work. Then our x, right, over here will be greater than 0.614 798, and then round up to 3 significant figures. So x should be greater than 0.615. Okay, so this over here would be our final answer, okay, for the whole reverse process. Okay, now let me take you through method 2, which is the critical value method, but using sample mean value. And this one actually looks a bit easier, but the calculator work would be harder. Okay, so over here we will have okay, this value over here is 0.6, right, the mean over here, and we're going to look at the sample mean value later, right? So means that we'll be looking at this and we'll get this right away lah. Okay, can so the thing is that let me write out our critical region first. Okay, now, so the critical region over here, right, okay, is that we will reject our H naught if the P value, right, so the P value, right, I'm going to do something like this, is this greater than this, right, is less than 0.10, okay, or in other words, the P value is less than this. Okay, can okay, and so with this, right, for melons to be heavier, okay, so H naught needs to be rejected. Okay, so this means that this probability, okay, this probability over here must be less than 0.10. Okay, and then, right, using GC, right, how do we use GC to get past this? Is that we'll look at this one, we look at the inverse normal, right? area is still the same 0.1, right? But the mean now we need to change. We need to change to the one which is in this distribution, okay, because we're doing from here directly, right? So 0.6, standard deviation would be the square root of this. So it will be the square root of 0.1 square divided by 75, okay? And this is a right tail test, right? And then we paste. Okay, so we will have something like this over here, right? And then you can see that actually it will tally with the previous answer. Okay, so from here, right, the x bar, okay, must be greater than 0.614798. So x bar should be greater than 0.615. Three significant figures. So this one looks a bit shorter, right? Because most of the work is done within the calculator itself. Okay, it will be done within the calculator itself, okay, from our GC. Okay, so then again, right, for the second method, right, do we need to state the critical region? Is highly advisable to state, because it's not all the time where we will follow this one over here. Okay, even for the previous one, it's not all the time we'll follow this. We need to look at the conclusion and to see, sometimes it's really less than. Sometimes, right, we do not conclude, right, we do not agree, so we have to be over here, right? Likewise, we have to be over here. Okay, so this value over here be 0.615. Okay, can. So the thing is that we are still advisable to write down our critical region, right? It's just that for this question, right, what we are taking is we are actually looking at the critical region. Okay, we are agreeing with the critical region or the rejection region, right? So this is why it looks a bit so that's why it looks a bit redundant. But if you were to think of it, like, let's say sometimes the question will say this, right? Then we need to flip this inequality already, lor. Okay, so so this is the concept that we have for question 5. So once again, set up step 1 to step 4 the same. Step 5 to 7, right, we need to jumble up some steps. So step 4 is this, right? Then step 5, we need to express our critical region, use the conclusion and work backwards. Okay, so this would be for question review exercise number 5. Okay, so let's continue with part 2. So without calculating the p-value, so we don't evaluate the probability. What's the conclusion of the test if his random sample of 75 melons show this? Okay, sigma x equals to 46.39. Okay, so the thing is that okay, for part 2, okay, given sigma x to be 43.69, right? So let us calculate from sample mean. Sorry, not from sample mean, right? The sample mean for the data given over here, right? That means the x bar over here would be sigma x over n. So this number over here, right, is actually our 46.39 divided by 75, our sample size. Okay, so this one over here will be equal to 0.61853. And if we were to compare with this critical value over here, because this 0.615, right, using the sample mean value is here, but if you use the z value, right, it corresponds to this particular z value, right? So this one over here, right, is greater than 0.614798. So it is on this side, okay, of the region, right? So it means that it belongs in the rejection region, right? Okay, so the conclusion of the test is that we will need to reject our null hypothesis. Okay, and because we reject our null hypothesis, right, we need to state our conclusion, so which is that there is sufficient evidence to support the claim, and so on, right? So the statement will be like that. Okay, so there we have it, the conclusion over here. Okay, so let's go on to review exercise number 6. So we have here a machine has produced a rope which has a breaking load which is normally distributed very nice, right? with mean 1000 newtons and standard deviation 21 newtons. So this one over here, once again, these are generic stuff in general. So this refers to the population parameters. Okay, so population mean and population standard deviation. Okay, so a new process was introduced and the quality control manager claims that the mean breaking load has changed. So this one over here, right, tells us that it has changed, but never tell us whether is it increase or decrease, right? So change meaning we will put this to be not equal to 1000 over here. And this one, because this is an inequality, this forms our alternative hypothesis. Okay, so to test, we have a random sample over here of 50 ropes. Okay, so this one will form our N. Okay, and the breaking strain of each piece measured and the mean for the 50 pieces of rope is K. So this mean over here, right, refers to our sample mean. Okay, so this one refers to our sample mean because this is the mean of the 50 ropes in the sample. Okay, so state the values of K. So means we are going to work backwards to get our sample mean to conclude at the 5%. Okay, so state the values of K, right? To conclude at the 5% significance level that our quality control manager's claim is justified. Okay, so this claim is justified. Okay, now so this one over here, right, this refers to the H1 being accepted, so means that we are looking at to reject our null hypothesis. Okay, so this is the idea that we're going to get from this question, and let us now put every pieces into the actual working. Okay, so once again, the setup phase, step 1, random variable and also the mu, population mean mu. Okay, so then step 2, null and alternative hypothesis, which we have already seen in the question. So this over here gives us our alternative hypothesis. So our null would come from here, right? So the null would be mu equals to 1000. This one over here would be, has changed, so it will be not 1000. Okay, so this one would be the control manager's claim right here. Okay, so this is step 2. Step number 3, set up the test statistic, right? So test statistic. Now, because we are testing for sample mean, right? We are going to look at the distribution of the sample mean, which is our x bar, and at the same time, this thing is already normally distributed, so we do not need to invoke the central limit theorem. We can just get our x bar directly. Okay, so x bar follows a normal distribution. The mean, population mean under h naught, so the h naught, we will use this as the mean. Okay, standard deviation would be 21, so this would be 21 square over sample of 50. Okay, all right, and because of that, right, I think it will be good to standardize because the standardizing procedure would be good, right? So x bar minus of our mean divided by standard deviation. Okay, and this one follows a normal distribution of 0 and 1. Okay, so there we have it, our step 3. Step 4, now we look at the test and we state our significance figure. So we're going to look at the two-tail test at 5% significant figure. So two-tail because of this and 5% because of this. Okay. Okay, so let's see the visual. Okay, so roughly we're going to see a bell curve like this. All right, so now we've already set up nicely already. So now let's do our testing phase, or to rework the testing part so that we can work backwards to get the unknown quantity. Right, so once again, I'm going to follow through with 2 different methods, and I will split a column for you like this. Okay, so we have it like this. Okay, so let's take a look at method 1, right? Critical value method using the z value. So same thing also, like So because now we already have our significance level, we have the probability over here 5%, right? So as a reminder, when we take these two areas, right, this 5% needs to be split to the two areas. Okay, so this tells me that each area over here, right, will be 2.5% or 0.025. 0.025. Okay, can so this is the what they call this, the area that we are going to get. Okay, so now once we mark out our probability, right, because we're using the critical value method, we will first look at where is this. Okay, we'll look at where is this. So what I'm going to do is I'm going to write out our critical region first, right, so that we can make comparison later. Okay, so the critical region, right, is that we will reject our null hypothesis, the rejection region, right, if the p-value, right, the total probability is less than 5%. Okay, and because of that, I'm going to look at the corresponding z value over here, right? So let me settle this one first, right? So we have an area over here, 0.025. In order to get this value, I'm going to use inverse normal. Okay, so let me show you my calculator, right? Inverse normal. Okay, the area over here would be 0.025, right? This is a standard normal distribution. So the mean is 0 and the sigma is 1. If I'm looking at the right tail and pace, I'll get this value over here, 1.95996. Okay, and on the other side, okay, you're using this area and doing the left tail, I'm trying to get this value over here. So same thing, I can do inverse normal and look at the left and pace. Okay, I will get negative. Okay, also because it's symmetrical about 0 lah, so you see that actually 1 is plus, 1 is minus. Okay, something like that. Now on another note, right, if you don't want to use left and right, you notice that because they're symmetrical, right, technically we can use the center. So the area on the side is 5%. This tells us that the area in the middle over here would be the remaining 95%. Agree? So we can make use of the inverse normal to look for the 95% in the middle, and I will use the center tail. Okay, and voila, I will get back these two same values as well. Okay, so if when the p value is less than 0.05, right, the z calculated, okay, the z calculated must be less than negative 1.95996, or z calculated be more than 1.95996. Okay, so this is our critical region. Okay, now, so the thing is that we settled our critical region already. Let's take a look at the conclusion, right? The conclusion over here is that the quality control manager's claim is justified, which means that we are going to agree with the null hypothesis, which means that we will need to reject our null hypothesis, right? So now, because we're rejecting our null hypothesis, okay, so for manager's claim to be valid, okay, we need to reject H naught. Okay, and to reject H naught, right, is indeed looking at the Z calculated over here, the same Z calculated over here, right? Okay, so with this, right, let us do some math to figure out what is the sample mean. So same thing, this Z calculated comes from this formula. So I'm going to make use of this formula to write out. Okay, so will be X bar minus 1000 over, okay, so 21 over root 50 will be less than negative 1.95996, or this value over here, okay, over 21 over root 50 greater than 1.95996. Okay, so after doing some math, right, you will realize that your X will be less, oh wait, yeah, this one will be less than 994.1792 to three significant figures 994. Okay, and same thing, x bar will be greater than 1005.8208. So x bar would be greater than 1005. Okay, I think let's honor the 3 SF, so maybe 1010. Add that to 3 significant figures. Okay, so this is our answer for the method 1. Okay, now let's look at our answer for method 2. Okay, so once again, this one we are looking at 0 and we are looking at the z-scores. Okay, for the first method. Now for the second method over here, we are looking for the sample value itself, sample data value, and the mean over here that we used over here was 1000, right? So we can look for this straight away, right? So the once again, okay, we look at critical region. Okay, we can state our critical region, and the critical region, right, corresponds to these two areas being 0.025 each. Okay, 2.5%, which makes up to 0.05, right? So the critical region over here, we will reject our H naught if, same thing, the P value over here is less than 0.05, right? Which means that this one over here, okay, the left one is less than 0.025, or the right tail over here is also less than 0.025. Okay, now so same thing for the manager's claim to be justified. Okay, we will need to reject our H naught. Okay, so same statement. And now, so instead of the z calculated statement that we wrote just now, I'm going to make use of this probability over here. Okay, I'm going to make use of the probability values over here, right? And from these values over here, right, we can make use of the calculator, right? So same thing, second distribution, inverse normal. So making use of all these things, right, we are trying to find these two values directly from the sample thing. So we have our 0.025, the mean is 1000. Now standard deviation would be this standard deviation over here, right? So I'm going to put in square root of 21 square divided by 50. Okay, so looking at the value on the left, okay, looking at the value on the left, okay, this will give me, okay, this one will give me 994.179, right? So this tells me that the mean x bar is less than 994.179. Okay, like that. Or, okay, or if we were to look at the inverse normal, and if you were to look at the right tail over here, okay, so straightforward, we can get x bar. This is 1005.82. Okay, so x bar would be greater than 1005.82. So writing to 3SF 994. Okay, and x bar more than 1010. Okay, so something like that. Okay, for method 2. Okay, so method 2 seems a little bit more straightforward, but the way we key in the distribution have to be careful, right? An alternative way, once again, is that we can make use of the 95% in the middle, right? So we don't have to key in twice, right? If you make use of 95% in the middle, you can actually see that it corresponds to these two values over here. Okay, so you can do this the smart way actually. Okay, so now the purpose is just for us to get the critical value, right? The interpretation comes from whether do we agree or whether do we reject the null or we do not reject the null. Okay, so for this question, once again, we need to reject the null, and that's why the presentation is like that, lah. Okay, so once more, if you look at the whole flow, this one is the setting up. Okay, maybe until here, right? And then here we'll need to do the test or to do the math part. So the math part comes over here using concepts from our normal distribution. So once again, we don't have exact p-value to do the calculation. So that's why we make use of critical value method, right? Mainly the z1 or even the sample data to find back the original value. Okay, so that's all for this video. I hopefully across these three videos you have a broader and better understanding on the topic of hypothesis testing. Once again, video 1 is the basic concept of hypo testing, elaborating about the 7 steps. Video number 2 is a forward experience, right, in which we use it to test and conclude. Then this video over here is a reverse process where we have already given the conclusion. We just need to work backwards to find our answer at the end. Okay, find the unknown quantity in the question, right? So that's all for this series of video. And let me know if you have any questions. Okay, so that's all and all the best.